What's going on, guys? So today I'm going to be talking about ions and isotopes. This is a continuation of the first lecture I've done on the general chemistry playlist. And ions and isotopes are very interesting to us because it's one thing to just have an atom that kind of just sits there and is stable and it doesn't really do anything. What's interesting to chemists is that what happens when we begin to add stuff from add stuff from atoms and take away things from atoms. What do the properties look like, and how do these things change? And so ions and isotopes is the foundation of chemistry in some sense, because chemistry is specifically looking at the interesting things that happen when we do things to atoms, not when we just observe atoms in a stable state. So ions occur when we add or take away electrons from an atom. Remember, the electron are the particles inside of an atom that are negatively charged. And so if we take away an electron, we are taking away positive charge, or negative charge. We're taking away negative charge, therefore making the atom more positive. Okay? And that's what I have in this first diagram here. So if I'm just going to come over here. So this is our atom. Okay. In red I have are the protons, and in orange are the neutrons, and in green are the orbiting electrons. And I took away this atom, or this electron right here. If we take away an electron, so we're taking away an electron. This is how we denote an electron, an E with a negative sign up on top of it. We take away an electron, we have this ion of this atom. This atom happens to be beryllium because we have 4 protons. And if you look at the periodic table, you'll see a Be next to the 4th atom, or the atom with the 4 on it. Beryllium is the atom that contains 4 protons, and if it's electronically stable, it's going to have 4 electrons. If we take away one of those electrons, it's no longer electronically stable, and we therefore have an ion of beryllium. And in this case, it's a positively charged ion of beryllium. And we call atoms with positive charges on them cations. So it has that prefix in there, ion, and the cat denotes the positive. Okay, so this is a positively charged beryllium atom, and it's a cation. We can also add electrons, so in this case we're adding electrons to this beryllium atom, and we've added one here. We're adding more negative charge to the beryllium atom, and therefore we have a negatively charged beryllium atom. And in this case, we call it an anion. And there's that prefix again, ion. So cat denotes plus, and an denotes a minus. So, and these are the charges again on the overall atom. Okay, here we have more protons than we have electrons, therefore making it positive, and here we have less protons than we have electrons, making it more negative. This is a cation and an anion. Let's move on to isotopes. So an isotope occurs when we add or take away neutrons from an atom. Neutrons are a lot heavier than electrons, so if we take them away, we are making the atom lighter. If we're adding them, we're making them heavier. So again, this is common sense. So what are we doing to this beryllium atom right here? Well, in orange, I have denoted these are the neutrons. So we have 1, 2, 3, 4 neutrons in this beryllium atom. And in this case, it looks like we have subtracted one. So we're taking away a neutron. In that case, we call it an N. Sometimes you'll see a 0 up there. And that 0 means no charge, not negative or positive, it's neutral. Okay? And this is an isotope of beryllium. And when we look at isotopes, we denote it like this. So our beryllium atomic symbol is Be, and the number of protons we put in the bottom left-hand side of the atomic symbol. So we have a 4 right here. And our neutrons, we have 1, 2, 3 neutrons here. Where we want to put that, we're not exactly going to put the number of neutrons up here, we're going to put the number of protons plus the number of neutrons up here. So 4 plus 3, so 4 plus 3, this is the number of protons, this is the number of neutrons, this is roughly the same thing as 4 plus 3 is 7, 4 Be. Okay. Is there a, so this is how we denote something like this. Okay? I just want to come back up here to the ions really quick, because we can also do something similar here. We have beryllium, and since it's a positively charged beryllium, we'll put a plus right there. If we want to be really, really complete, we can put a 4, and we have 1, 2, 3, 4, so we have, this becomes an 8. Okay, so this is really compact notation without us having to draw these diagrams out. Okay, so here again we have, so I'll do it for this one too. We have beryllium. This one has a negative charge on it, so it's an anion of beryllium. We didn't change the neutron charge, so this becomes, this stays the same as this. Okay, so these are all equal to each other. This is equal to this scenario, and this scenario is equal to this scenario, and this is equal to this scenario. So I hope that makes sense, and with later lectures, this will come in handy a lot. And so if you like the way I lecture, if you like the way I teach you guys this kind of stuff, please visit my website at tristancarmacy.com, and I will see you in the next one.